Hello and welcome. In this video we will cover the basics of dynamic simulation, what it is used for, and what we can simulate with it. And I will give you an overview what I plan to show on this channel in the future. A dynamic simulation is useful to analyze the behavior of a system over time. We might be interested in the oscillation of a machine, the temperature inside a cooling loop, or the velocity of a vehicle or an object moving through air, like the baseball flying through air shown in this animation. In this video we will cover some of the basics regarding dynamic simulation before we take a look at concrete simulation examples with code, where I will show you how to run a basic simulation in MATLAB. This is the content of the next video to be released in this series, and I will link it in the video description, so best check if it is available already. The basic idea behind a dynamic simulation is to describe the change in a system depending on the current configuration, also called state, of the system itself. And we use that to first calculate the change of state, and with that a new state of our system. If we take this vehicle for example, and we draw in forces acting on it, we can see that our engine tries to push us forward, while the air resistance and the inertia of the vehicle try to hold us back. The force of the engine is assumed to be constant here for simplicity, but the air resistance is directly influenced by our current velocity, where the velocity is one of our system states. The faster the vehicle moves, the higher this force holding the vehicle back will be. The residual force, so the difference between everything propelling the vehicle and everything holding it back, will lead to an acceleration and a change of our system state, because the acceleration will change the velocity. As time progresses, our vehicle will get faster and faster, our acceleration will go down because there is less residual force accelerating our vehicle. To figure out how our vehicle will accelerate in detail over time, we can create and run a numeric simulation. In such a simulation, this updating of the state can be done numerically, so we do not have to worry about solving any differential equations ourselves. What the numeric simulation does is the following. It takes the state and the equations we provided. So for the example of our vehicle, we take the velocity, calculate the forces, and with those forces we can calculate the acceleration of the vehicle. Then we calculate the velocity for a point in time in the future. This is our first simulation step as shown here. The position is shown on the y-axis and the time on the x-axis. The state, so our position, is one of those points here. As we accelerate, our velocity increases, which is noticeable by the increasing slope of our tangential line in this point of the position curve. The slope corresponds to the velocity at this point in time. We can then move along this tangential line by a certain time step. Here we repeat the same again and again and again. For our first simulation examples that we will look at in the following videos, we will treat the actual simulator part that takes care of this updating of the states just as a black box. There are a few different techniques of doing that, and the video showing what happens inside the simulator is planned to be released in about 6 months. And there we will take a closer look what happens inside such a simulator, how the time step is determined, and so on. I am planning to release some videos covering dynamic simulation throughout the year. In the next block of videos we will take a look how to create some simulations ourselves directly. We will use simple systems at first because I want to put the focus on actually creating some simulations. For those examples we will use text-based simulation, but maybe in the future we will take a look at a tool like Simulink. In the next block of videos we will then take a look at how the simulator, so the numerical wizardry behind everything, works. In this block of videos we will also take a look at Lagrange's principle and how we can derive the equations of motion required in simulation for more complicated systems. In the last block of videos I'm planning to show you some simulation examples for systems with an active controller and how those simulations can be set up. Thank you very much for watching. Share the video with colleagues or fellow students, and make sure to subscribe and turn on notifications to not miss any of the videos in the future. See you next time. Bye for now.